Chemistry 107, Experiment 6, Acid-Base Titration. Titration is an analytical technique used to determine one solution that is added to another using a burette. The solution in a burette non-solution is added until the reaction between the two compounds is complete. An example of titration reaction, acid-base, or sometimes called neutralization reaction. Neutralization reactions are one of the most common types of chemical reactions that proceed sufficiently to the right to completion, and so it could be considered quantitative and can be used to determine the concentration of acidic or basic solutions. In this experiment, the titration is performed by adding a non-basic solution called titrant from a burette to a measured quantity of a non-acid solution called analyte until the number of moles of OH minus is just equivalent to the number of moles of H plus. This point called equivalence point. Equivalence point is the point at which both reactants, titrant and analyte, are equivalent. The equivalence point is detected by an indicator. Indicator is organic compounds, which changes color as close to the equivalence point. This point is called endpoint. The endpoint is the point at which the indicator changes its color. Point and the equivalence point are considered approximately the same, and at this point the number of moles of acid and the number of moles of the base is equivalent according to the balanced equation. If the mole ratio is 1 to 1, the equivalence point here means the number of mole of acids equal the number of mole of base. The concentration of the standard solution or titrant used in the titration should be well known. In this experiment, NaOH is used as standard solution, but NaOH is secondary standard. Secondary standards mean it is unstable toward moisture. It's called hygroscopic, so its concentration varies with time and needs to be standardized. Standardization is the process of determining the exact concentration of a solution before titration. The primary standard, which has precisely known concentration that used to standardize the NaOH solution, means to determine exactly the molarity of NaOH before used, is called potassium hydrogen phthalate, KHP, as shown in the reaction below. In the standardization part, a known weight of KHP is dissolved in Erlenmeyer flask with distilled water and titrated with NaOH. Titrated with NaOH solution in the presence of phenolphthalein indicator. At the end point, when the phenolphthalein changes its color from colorless to pink, we reach the end point and consider it as the equivalence point. According to the equation, KHP reacts with NaOH in 1 to 1 mole ratio, so at the end point, moles of KHP equal moles of NaOH. The weight of KHP and the molar mass of KHP used to calculate moles of KHP, which is equal to moles of NaOH. From the calculated mole of NaOH and the volume required to reach the endpoint, we can calculate the molarity of NaOH used. The second part of this experiment, titrating an unknown solution of sulfuric acid with the standardized NaOH. Sulfuric acid is a diprotic strong acid. Diprotic means react with 2 mol of NaOH. Contains 2 protons. React with 2 mol of NaOH in an acid-base reaction. In this part, a known measured volume of H2SO4 unknown is titrated against the standardized NaOH solution using phenolphthalein indicator. At the end point, we can calculate the molarity of H2SO4. In this reaction, the mole ratio of H2SO4 and NaOH is 1 to 2 mole ratio, which means that at the end point, moles of NaOH equal 2 moles of H2SO4 according to the equation. Now, molarity of NaOH from part A is known, and the volume needed to reach the end point for NaOH is known also, and we can calculate moles of NaOH, and from moles of NaOH we can calculate moles of H2SO4. In this experiment, the first part, first determine the molarity of NaOH solution by titrating against a primary standard acid KHP. Then use the standardized NaOH solution to determine the molarity of a sulfuric acid unknown. The procedure: A. Standardization of NaOH. 1. Dissolve 0.4 gram KHP with about 30 ml distilled water into a clean airmer flask. Add 3 drops of phenolphthalein indicator. The colorless solution now titrated with NaOH until it changes to pink color. From the volume and the mass of KH, the volume of NaOH and mass of KHP, calculate the molarity of NaOH. Part B, titrating an unknown solution of sulfuric acid. Transfer 10 ml of the unknown sulfuric acid solution using the pipette into a clean airmer flask. Add 10 ml of distilled water and 1 drop of phenolphthalein indicator and titrate with standardized NaOH. Record the volume and calculate the concentration of sulfuric acid in unknown solution. Example: the standardized NaOH solution, the concentration 0.119 molar, was titrated against 28.1 ml of H2SO4. The volume of standardized NaOH solution needed to neutralize the H2SO4 was 24.28. What is the molarity of the H2SO4 solution? From the molarity and the volume of NaOH, you can calculate the number of moles of NaOH and convert to the number of moles of H2SO4 according to the ratio 1 to 2 from the balanced equation. You can calculate molarity of H2SO4. The second example, in an acid-base titration, 20.15 ml of NaOH solution was required to neutralize 0.491 gram of KHP. The molarity of NaOH solution. From mass of KHP and its molar mass, you can calculate number of moles of KHP. Moles of KHP equal moles of NaOH, and so you can calculate the molarity of NaOH.